In a spherical surface in the convex shape, the input ray is shown going through the curvature and refracted towards the center of the line using Snell's law of refraction. And in the concave shape, the light will go away from the center line, unlike the convex shape shown here. And this gives it the glass index N, and with physical prisms of light going through, the wider the prism, the more angle towards the center of line will be shown as such.
Hello class. Today we'll be looking at some fun equations for mirrors. First, we have the equation to find focal length. All we need is the object's distance from the mirror and then the image distance inside of the mirror to find the focal length. Another fun equation we can do is to find magnification, which we take the image distance and we divide it by the object distance. That's pretty easy. So, read this expertly created problem and feel free to pause the video whenever you want, just to really get this down and solve it. And when you're done, shout your name 3 times. Okay, now when you're done, does your work look like this? Because this is right and not wrong. The answer for Q should be 15 centimeters using this basic math here. If you have 1 over 30 plus 1 over your variable equals 1 over 10, you subtract 1 over 30 from both sides. And then you get 1 over your variable equals 1 over 15, and then this is just basic multiplication, Q equals 15 centimeters. And to find the magnification, we simply take our image distance and divide it by our object distance. It's pretty dummy proof, and you get that answer. And there is no unit for magnification, should be clarified. It is. Yes.
Weird. The visible light that we see is only a small part of the electromagnetic wave spectrum, which goes from gamma rays to radio waves as the wavelength increases. For visible light, the lowest is purple at 400 nanometers and the highest is at 700 nanometers wavelength. And so, as it increases, it goes further down the spectrum. And that's why when you put, so all light has the same speed, but the wavelength changes the color. When you put a laser through a prism, refracts on these different sides and then changes wavelength, and that's why you get a spectrum of light.